Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video, we'll discuss about question number 3030 of NEET Physics paper 2015. Students, let us solve the question number 30. Consider third orbit of helium plus. So it is like hydrogen-like atom. One electron is removed. So it is like hydrogen-like atom. Because if you want to apply Bohr's postulates, then it should be hydrogen-like atom. So helium plus, using non-relativistic approach, that means the speed of the is not comparable to the speed of light, that we are not going to take into consider those relativity consideration. Then the speed of electron in this orbit will be constant. The speed of electron in this orbit will be constant. Z is 2 and H is this one. So consider N is 3, third orbit. Helium plus, that is, it is hydrogen like. And the charge of this, if you think of He plus, this is the nucleus and the electrons, one electron is revolving here. The nucleus is 2e because it contains two protons, which is 2e, and this is the N is 3. In any way, now here the Z is 2 obviously for helium, that I have taken 2e. Planck's constant is given as this, and what to find is the speed. The speed of the electron in this orbit will be how much? This is the constant 1 over 4 pi epsilon naught, which is 9 10 to 9. So basically we are interested in the speed. So we know that from Bohr's first postulate that the centripetal force mv square by r is provided by the electrostatic force of attraction between the electron and the positively charged nucleus, and this is the v of third orbit, say any orbit, nth orbit. So that is Coulomb's law. K, electrostatic force from Coulomb's law, is K Q1 Q2 over R square. 1 R cancels. K Q1 Q2, this is 2e, this is e, so it is 2e square divided by R, which is mv square. This I will take equation 1, and this is first postulate. What is that the second postulate? Bohr second postulate. That is the angular momentum of the revolving electron is integer multiple of h upon 2 pi. So I'm interested in this mv square is this, and if I divide these two equations, then I will get, because n I have to put 3 here in any way. If I divide these two equations, because I can bring this r over here, I bring r over here and this is divided with this, then what I will get? I'm just writing those two equations one over another. mv square is k 2e square divided by r, and here mv is nothing but nh upon 2 pi r. These are the two equations. If I divide these two equations, then what I will get? This mv will cancel and one v is left. This implies this, and here this r 1 over r is here, 1 over r is, that will also cancel out. 2k e square divided by nh over 2 pi will come up. So it is 4k e square pi divided by nh, n is 3, so 3h. Okay, so this is what is the value, and we have to just solve it to get the answer. So it is k value, I'll just substitute, I will keep on substituting those values. I know 4 is 4, k is 9 10 raised to power 9, e is 1.6 10 raised to minus 19 square, this pi is 3.14 divided by 3h, h is 6.63, now that is here given 6.6 10 raised to minus 34 joule second. Now I have to solve this to get the answer. Now this v comes out to be, if I solve it, then probably I will get, if I see the answers, then it is in terms of 10 to the power 6 or 8 something, but it is not 10 to the power 8, it is always 10 to the power 6. So in terms of 10 to the power 6, I will just try to find out without going for actual calculations. Let me have a rough calculations. This is 3, so 3 3 is 9. This is 6.6, and suppose this is 6.3.2. This almost is double. This is almost double. So we'll calculate that way. This is double. 6.2, probably 3 I'm getting, but I just cancel out for in terms of approximation, because I'm not interested in the exact calculations, because that varies. You can see there is a variation of 0, 2 and 1, so I'll just have a correct answer. Or I could have gone for these two colors. Anyway, this is 4, this is 1.6, this is minus 34, this is minus 38. So this becomes, just let me have one more, 4 into 3, 10 raised to the power 9, 1.6 into 1.6 because square, it is minus 38 divided by, this is 10 to the power minus 34. Okay, approximately this one. This is 34, so it's minus 4 is left, but this minus 4 is left, and from minus 4 I have 9 here, so it's 5 left, so 10 raised to power 5, 4, 3, 1.6, 1.6, 10 to the power 5. Now because it's 10 to the power 6, I'll put 1 0 over there and divide it, so this becomes, multiply 10 and divide 10, so this is 12 into 1.6, 1.6 divided by 10 into 10 to the power 6. So in terms of that, if I go for the calculation, approximately I can get the answer. Okay, this is if I take approximately 1.5, 1.5, then this is 3 by 2, 3 by 2, so it is 12 into 3 by 2, 3 by 2 and by 10. Okay, now this is 6 and this is again it is 3, so 27 by 10, approximately it is I'm getting here 2.7 10 to the power 6, approximate, all calculations approximate, and that is what you should solve also, 10 to the power 6. So approximately I'm getting 2.7. If I go for actual calculation, I might end up here, because that has to be more, so it is the it might be this also, that I have to go for actual calculations, because this where I have taken those approximations, I have to see it. So here it is more, I have taken less, so, and here it is more. When I cut this, it would have been more than this. 2 is there, that 2 I have not written, so this 2 is also there. Okay, because when you cut this, approximately it becomes 2 is there, So 2 is finally divided. 2 is divided. From it 2 is divided is approximately 1.4. Approximately 1.4 10 to the power 6. Therefore, this is the correct answer. If you go for actual calculations, you will always land up with this answer. So if I go for such type of calculations and still get the answer, if the answers are very close, then you go for actual calculation. Otherwise, you can go for this type of calculations. So this is the correct answer to this question. Okay, thank you.